Lesson 1-6, position, velocity, acceleration, and using your calculator to differentiate. So here's some vocabulary we need to know. Position function. It gives the location of an object at time t, and these are the different ways that you might see it. S at t, x at t, y at t. The velocity is the change in position over time. If the velocity is positive, it could move up or to the right or forward. If the velocity is negative, it moves down or to the left or backward. Velocity tells you how fast you're going, and it gives you direction. Acceleration is the change in velocity over time, usually with an A compared to a V. The initial position, you use 0 and plug it into the position. The initial velocity, you use 0 and plug it into the velocity. Speed is the absolute value of velocity. It's always a positive number, and it never gives you direction speed. Displacement is the difference from where you start and where you end. Total distance, you have to understand the distance you went in all directions during that interval. So the distance you went to the right, the distance you went to the left, and then you have to add it up. So total distance takes a little bit longer to do. All right, example number 1. If you are given a position equation, how do you find velocity? And the answer is do the derivative. How do you find acceleration? Do the derivative. So we do the derivative for velocity and then the derivative again for acceleration. That's the connection here between them. So derivative, derivative. Keep taking that to find that. In example 2 to 11, we're going to use this equation to answer this. What's the initial position of the object? So we're going to plug in 0, and the answer is 24 feet. And I just plugged into here. What's the velocity? Well, I first need to know the velocity equation, so I'm going to take the derivative. And then after I take the derivative, I'm going to plug in 1. If you plug in 1, you get 24, right? And it's negative 24, and that's feet per second. So not only does velocity tell you how fast you're going, the direction. So in this case, on a horizontal line, so in this case, we're going left when it's negative. What's the speed of the object? That's the absolute value of the velocity. So if the velocity at 1 is negative 24, then the speed would be positive 24 feet per second. What's the acceleration of the object? So we need to find the acceleration. To remind you, the velocity was 48t squared minus 72t. So acceleration would be 96 minus 72. Plug in 1. So it's 96 take away. So again, it's 24. Now how do I write acceleration? So acceleration is the change in velocity over time. So velocity is feet per second, but it's feet per second per second. So acceleration is written as feet per second squared. Well, velocity was just written as feet per second, and position is just feet. Knowing how to write the units is a part of this lesson. When is the object at rest? An object's at rest when the velocity is 0. So we take the velocity, make it equal to 0, and solve it. So we can factor this. 24 goes into both evenly, and then solve it from there. So 24t gives me the answer 0. And then if I add 3 and divide by 2, I get the 2 times when the object is at rest. Number 7, when is the object moving to the right? Well, when the velocity is positive, it's moving to the right. So what we're going to do is draw a number line. This is going to represent the velocity. On this number line, I'm going to put down when the object is at rest. So at 0 and 3 over 2, which is really 1.5. That's when the object is resting. It's not going right or left at those times. All other times, it's going one direction or the other. Now, I'm going to plug in a value that's smaller than 0 into the velocity. So if I plug in -1 into the velocity and I solve it, a negative times a negative is positive, and -1 squared is positive. So -1 gives you a positive value. That means from -infinity up to 0, it's moving to the right. Next, I'm going to pick a number in the next interval. So I'm going to pick +1. If I plug +1 into the velocity, I get 48 take away 72. So from 0 to 1.5, the object's moving to the left. And then pick a number bigger than 1.5. Doesn't matter what number it is. And then if you plug it into the velocity, you get a positive answer. And I don't care what the actual number is right now. I'm just seeing if it's positive or negative. So this means it's moving to the right. So when is the object moving to the right? And so it's when the velocity is positive. So from -infinity to 0, the velocity is positive, so it's moving to the right. From 1.5 to infinity, the velocity is positive, so it's moving to the right. We're running out of space here. So from -infinity to 0 and 1.5 to infinity. When is the object moving to the left? We already did this hard work. So it's moving to the left here from 0 to 1.5. It's moving to the left. When is the velocity of the object equal to 54 feet per second? So take the velocity and make it equal to 54. This one's a calculator question, so we're going to use our calculator to solve it. See if we can get this focused in. So I want you to press menu and then algebra. So menu and then algebra and then solve. That's number 1. And then we're going to write in. So 48t squared subtract 72t equals 54. And then I have to go comma t. Now go control enter. And those are the 2 times where the velocity is 54 feet per second. So at those 2 times, the object is moving at that speed or velocity. All right, what is the displacement of the object? So the displacement is the position. So we take the position and we plug in 2 and then plug in 0 and we subtract those 2 positions. That's what's going to give me the displacements. We're going to use our calculator again. I'm going to type in the position equation in the calculator so that it's easier to work with. So I'm going to press this toggle button, go to the graph, I'm going to erase what I have there, and then I'm going to type it in. But I have to use the variable x, which is fine. So the position equation is 16x cubed subtract 36 x squared plus 24. So 16x cubed minus 36 x squared plus 24. Now I'm going to go press the toggle button again, and that's now been defined in my calculator as F1. So F1 at 2, subtract F1 at 0, and that's it. And so the answer is -16. and that would be in feet. And the reason it's negative is the displacement means it's moved to the left so from the initial position it's moved 16 to the left after 2 seconds. Alright, next part is the total distance from 0 to 2. To understand total distance, we need to understand if the object has changed direction in that interval. So when I look at this number line here, from 0 on, notice it changed direction at 1.5. So from 0 to 1.5, it's going left, and from 1.5 and on, or to 2, it's moving to the right. And what I'm going to do is, I'm going to find the distance here to the left. I'm going to find the distance here to the right, and then I'm going to add the two answers together as positive numbers. So how do I find the distance traveled between these? Is I'm going to use the position again, and so I'm first going to do this, but I'm going to use absolute values, so the answer, whatever I come up with, is going to be a positive number. So let's do that. If you want to know where the absolute value bars are, beside the number 9 is this button. Press it. And that's absolute value, so press enter. And then inside, I'm going to press F1 at 1.5, subtract F1 at 0. That's it. And I get the answer positive 27 because of the absolute value bars. That's 27 feet. Now, I'm also going to do this from 1.5 to 2. So that would be S at 2 minus S at 1.5. Again, we only want the positive answer there. So absolute value, now it's at 2, subtract, and 1.5. And you get the answer 11. So the object went 27 feet to the left, then it changed direction and went 11 feet to the right. And then what's the total distance? Is you add these up. So the total distance is 38 feet because you added up both directions. Number 12, 13, and 14, and 15. This is a graph of a position of a radio-controlled car. So the initial position is 0, and then it moves away from you, and then as it comes back, at the end, it came right back to you. So this is the position of the car compared to where you are. Question number 12, was the car going faster at A or B? Which one's steeper, A or B? Which one, if you drew a little line through it, would be steeper? So the answer is B because it's steeper. Oops. When was the car stopped? So the car is stopped when the position doesn't change. So because this is a position graph, right here between C and D, the position stayed the same number. So when it stays the same position, it's at rest. It's stopped. Number 14, at which point was the car's velocity the greatest? So where is the steepest positive slope? So that's going to be at B. At which point was the car's speed the greatest? For this one, it could either be positive or negative. Which one is steeper in either direction? And so E, if you drew it, is a little more steeper than B. Speed is the absolute value, so it changes it to a positive number. So at E is the steepest part of the graph. B is the steepest positive slope. Here, this is even steeper if we change it to a positive number. Here's a vertical motion example. Suppose the position of a ball is given by this, and it gives you the height of the ball and you're throwing it off a cliff. The initial velocity, we would have to take the derivative. So 2 times negative 16 and 48. And then I would plug in 0 for the initial velocity. So that would give me 48 feet per second. So the initial velocity, the ball was thrown at 48 feet per second. At what time does the ball hit the ground? That's when the position is 0. So we make it equal to 0. We can actually divide everything by negative 16. What is that? That would be 10. And then we can factor. Now, we don't want the answer that's negative in this case. We can't have a negative time because there's an actual person on a cliff throwing a ball. It's a real world situation where time can't be negative. So the only answer here is positive 5. This one gives me a negative answer, so this one gives me the answer, how long it takes for the ball to hit the ground. At 18, what time does the ball reach its maximum height? So if you throw a ball up in the air and then it hits the ground, when it changes direction is when it reaches its maximum height. That's the velocity. So you take the velocity, and when it changes direction is when the ball rests just for a moment. So we're going to take the velocity equal to 0, and then we're going to solve it. Oops, that's negative 48. When you divide it, it's a fraction. 48 divided by 32. 16 goes into both evenly, so that's 1.5 seconds. So at 1.5 seconds, the ball reaches its maximum height, it changes direction, and then comes down. Last part, we need a calculator. Ignore all of this. This is garbage. This is not your calculator. If this is the function, find the derivative. Ignore this. Let me show you how to do it with our calculator. So to find the derivative at a value, like at 2, let's see if it focuses in here. All right, we're going to press the menu button and then calculus and then derivative at a point, number 2. The variable is x, and then the value that we're looking for is at 2. And then you type in the function. So that's x cubed plus 3 to the x. And that's it. Press Control Enter, and you have your answer. You don't have to round. And there's your answer. So here we have another one. Find the derivative at 2. Again, ignore all this stuff. So can you find the derivative? And then can you graph the derivative? All right, here we go. So to find the derivative, menu, calculus, derivative at a point. And we want it at what value? At 2, again. And then type in the function. So ln, ln, that's here in blue, right here in the bottom left. So control and then e to the x. And then type in x squared, subtract 3. You get the answer 4. For the derivative at 4, highlight, go back and highlight it, press enter, and now change it to a 4. And you get 0.615. And then we want to graph the derivative. So to graph, press the toggle button. Let's go back. Oops, let's press tab. and go back up and erase this. We're doing the derivative. So press the button beside the 9 and you'll see a derivative notation. It's right here. This is the one we want. Press enter. The variable is x, and then we just type in ln x, or ln, and it's x cubed plus 3, right? Or x squared. X squared, take away 3, sorry. And then if you want to expand out so you can see it a little bit better, we can do that too. You can press menu and window and just do a standard, number 5, kind of a standard view of it. Now, believe it or not, that's not the accurate graph because the middle part of the graph doesn't exist. See, a logarithm can't have a negative number inside. So all things from root 3 to negative root 3, the middle of the graph would give you a negative answer. So I don't know why the calculator gives you an answer for this derivative in the middle, but it's a domain restriction. So the middle part doesn't exist. It's only the right and the left. The right and the left. Oops. All right, last one. If the function is this, what's the derivative at 0? And the answer is it doesn't exist because there's a turning point there, a sharp turn there. What does the calculator do? Let's see. Will the calculator handle that and say undefined? I bet it will. So we can go back here. We're going to press menu. We're going to do calculus and derivative at a point. And the value is at 0. And then the function is the absolute value of x. Let's see what it does. Oh, it says positive and negative 1. Well, because there are two answers at the same time, therefore the derivative doesn't exist because they don't agree on the answer. You can't have two answers at the same time that are different for a derivative at a value, so the derivative doesn't exist. All right, Mr. G Math, over and out. I'm proud of you, and now we're on to our assignment.